Python 3.12 released exactly a week ago, and you know what that means? This entire month is going to have content dedicated to that, apart from one video. There's one video in the middle that's going to be different, but the rest is all going to be Python 3.12 related. I put out a poll on my YouTube community, and most of you wanted to see typevar stuff, all the type syntax stuff most. So I'm doing that first, even though some type checkers aren't readily available with this functionality yet. MyPy hasn't caught up, but Pyrite already knows what's up. So I'm actually going to be using Pyrite in the CLI to be kind of showing and verifying everything. So we're kind of going to go from least to most impactful / important, because it also happens to go from least to most complicated. So it's just the way it is. But yeah, we're going to start with typedict's quag unpacking. We're then going to move on to the override decorator. Then we're going to move on to the type parameter syntax. So let's begin. So if we create a new file, we're just going to call this quags, I guess. Files.py, and we're going to do from typing import not yet. I'm already getting ahead of myself. Type dict and unpack. We'll come back to the not required in a bit. And then we're going to define a profile. We're going to ignore those imports for now, and we're going to define a profile which takes various quags, either string or integer. So this is the kind of the old way of doing it for now. So for kv in quags.items, print just a simple little utility to print quags to the terminal in a way that is cool. So if we do that, and then we do profile, yeah, that's what I want, profile. So I was just looking at my notes thinking, what am I doing? And then my age is 20, I'm 25. In my notes I say I'm 24. I forgot my birthday's gone since then, bloody hell. You know you're getting old when you don't remember how old you are. So if I do py quags.py, we'll see that it just prints, it's a very simple utility function. What I want to keep in mind is this string or int. So what this is saying at the moment, and this is the way you do it in Python 3.11 and below, is that your quags can be of type string or int, and that applies to any keyword argument. There's no distinction as to which ones are strings and which ones are integers. And this is where our type dict comes into play. So we can do, if I just kind of move this a bit over so we have a bit more real estate. If we do class, let's say attributes, let's do quags. Let's call it quags. That seems potentially a bit more suitable. We inherit from type dict, and we just create a normal type dict. I've already done a video on type dicts. If you want to go see that, that will be in the cards in the top right of your screen as you see it. And now instead of this, we can do unpack quags. This is why we needed the unpack. So what this is doing is it's taking the quags, which is a type dict, it's then unpacking it in and of itself, and then applying, or I suppose mapping, the unpacking to the actual quags themselves. So now it would expect a name and an age to be passed through, and it would expect the name to be a string and the age to be an integer. So if we run a Pyrite on this, and at the moment I do have to specify that the Python version is 3.12. I don't really know why that is. Maybe it's just the way that PyEnv set everything up. But as you can see, we get no errors. If I were to set this to a string, we suddenly get an error saying that literal 25 cannot be assigned to parameter of age of type int. So it's actually able to see that this is a type int. It's able to, do all the unpacking and everything. And that's really cool. If I were to get rid of age entirely, it would then also say that you're missing the parameter age, because currently by default it's set to be required. Now if you saw the typedict video, you'll know that we can import not required, and there is another way of doing this, but I'm not going to bother showing that. You can look at that typedict video if you want to see that. This is the preferable way, and then you can set non-required in here. So now we are requiring quag with name string, name, key, name, value, string, there we go, key, age, and then the second one, key, age, that's not required of type int. So if we do that, after that abysmal explanation of what I was doing, we can see that we now get no errors because it's not expecting one for age. So if you were to put it back in, it would, and you can actually see the function signature is updated now, which is cool. Then we also get no errors. So that's all sorted. That is how the Quark system works. It's quite nice. I can sort of see a use case if you have a lot of keyword arguments, and you want to specify like a more detailed schema for these arguments, perhaps without like polluting the code, because code quality analyzers tend not to like huge swathes of arguments or parameters in there. So it could be useful for that, but I would say this is probably the least useful of the three. Which brings us to the second most useful, or second least useful, depending on your psychological outlook. There we go, took a while to get to the word. The override decorator. So if I do override.py, and then say, for example, you have a class called fruit. And this fruit can grow, and when it does, it talks to you, because it's a bit weird like that. This lives in the world of Super Mario Wonder. And it says, I have grown, like that. And then it has a similar method called eat, which prints enjoy your meal. And then you have a second class called banana, which inherits from fruit, which also inherits the grow method as it comes, but then redefines or overrides the eat method to say enjoy your potassium instead. Now, as it stands, there's nothing wrong with this. But what if you decided to change a method name in the base class to consume, and then you forgot to change it in the subclass? This eat would still be valid as a method in and of itself, but it would be now disconnected from the parent class. So the banana and the fruit have different behaviors, and we don't want that. It's going to cause crashes and all sorts. So what we can do is we can do from typing imports override, and it's good because override isn't actually in the autocomplete at the moment for VS Code, which is wonderful, but it does exist and it does work, which is good to know. And then we can set, if we say that this is an override of the eat, and then we load pyrite up again, and that's the wrong file. Let's actually get it to use the correct file. So override.py. You can see we get an error saying method eat is marked as override, but no base method of same name is present. So it's now able to see, oh, we've reformatted our base class and we've forgotten to do it for all the children. And now we can go and change this as well. And voila, we have no errors. There was actually, if you want this on earlier Python versions, there is actually a library on the Python package index that's been able to do this for some time. It marks its compatible versions, I believe, as 3.5 through 3.9. So its status for 3.10 and 3.11 is unknown. I don't know if it works or not. Haven't tried it myself. But you could, quite easily in a requirements.txt file set an environment marker saying if Python version is less than 3.12, then install this override decorator, so you can use it across all versions of Python. It's very similar to like the toml that came out in 3.11, where there was a Python package index package that could do it for some time, but it just wasn't in the standard library until then, and this wasn't until now. It's a good one to have, and it's certainly, I didn't know about the Python package index one before all this. And it's just a really good safety net to have in case you do ever do any breaking changes, or you need to do any breaking changes for whatever reason, just to absolutely make sure that everything is correct in the right place. The third and final thing that I want to talk about in this video is the type parameter syntax. This is arguably the biggest typing change in this version, but it's also the most complicated to explain, which is why I've left it for last. So if we were to, from typing, import type var generic iterable and iterator, and I'm going to be explaining this in the context of the older system, so you can kind of understand how to change into the newer system from the older system. It might make a bit more sense that way. And if we were to have a class of immutable list, and that inherits from generic tco, and then we define a covariant type by doing this, so set that as the name as tco and covariant equals true. And then we were to have and I'll talk about covariance in a second. That name like that, nope. Items like that, and that would be an iterable of tco. Have self.items equals items. And if we were to also create an iter for it, self, and then that returns none. We then return iter self.items. So this is our immutable list class. It is kind of a very simple implementation of a list that you can't change, basically, but you can iterate through, which is cool. So once you set the list, you can't change it or anything. We then have, say, your class employee. So at this point, some people might realize that this is a modified example that I'm kind of taking from PEP 484, but I've modified it to be more useful in this context. So we just set a name like that, and if we set manager employee, and then we set that as just the same thing. So what we mean by covariance here is that we have a class called employee, and then we have a subclass manager. At any given point in time, class manager may or may not use any interfaces provided by its supertype, which in this case is employee, because the manager could potentially override something, and it could do something different. Maybe it breaks the list cost substitution principle. Hopefully, if you're using the typing library, it probably wouldn't, but it could. We don't know. Which is why the two are considered invariant unless you explicitly specify otherwise. And covariance is one of the ways of doing that. If two types are covariant, the subtype should be able to use everything that the supertype can, and will be perfectly compatible with the supertype. So what that means here is that the manager class will be able to use everything from the employee class, and it hasn't changed or broken anything. Contravariance is the other way around, but we don't need to talk about that in this video. I'm probably going to have a more detailed explanation of these typing contexts in a future video. This is mainly for people that kind of already know what they're talking about, but I'm providing these explanations for people that might not know, just kind of at a base level. Hopefully that makes sense. So if name equals main, and we have a run guard down here, and then we set people as a list of a mutable list, and then we provide a list called employee John, and then his manager Jane. So here we're passing employee and manager, the immutable list, so all the items in the immutable list, and therefore how you iterate through everything you do with each item in this list should be able to do all of the same things, which is where this covariance comes from. If we were to do that, and then if we ran pywrite, we would run into an error. How have I done that? It's not supposed to happen. Oh, here we go. This iter is supposed to do an iterator of tco. There you go. So it's an iterator, and it returns an iterator of our type of the items. And now if we run pywrite, we should get no errors at all. There you go. That is the beauty. I did that on purpose. That is the beauty of type checkers. They can find errors like that you wouldn't otherwise have known. So this is a very basic example of a generic class. How we can do that in the new Python system is by not importing type var at all, not importing generic at all, getting rid of that completely, and instead of using, oh bloody Nora, instead of using normal brackets, we can use square brackets and provide t.co in here. Or you can provide this as t if you want, it doesn't matter, you can provide this as anything. But this functions exactly the same, as it did before. You don't even have to explicitly specify that the type var is covariant. It seemingly, according to PEP 695, just knows, which is quite convenient. It doesn't have any bounding parameters automatically, but I'll come to that in a second. And you can see, so anything that's defined in here will then be used here and here. And this Tcode is scoped to this class. So if you were to use it somewhere else, it would be a different type var. So you don't have to define a billion type vars to be able to use it, which is quite nice. And if we were to load Pyro again, we can see that we have no errors. So it's all well and good. If we were to provide a number 4 here, we'd still get no errors. But if we were to say do for person in people and then print person dot name, then we would get an error because the type checker is able to realize that our integer doesn't have a dot name, which is fine. It's great. But what if there was another way? What if you only wanted your immutable list to be able to accept objects of type employee or more specific in the first place? Well, you could do that just by doing this. So this colon and then our class type here replaces the bound keyword argument of type vars. And now if I were to run it again, we'd get a different error saying argument of type list employee cannot be assigned to parameter items of type thingy because type literal 4 cannot be assigned to type employee. And almost a PyCharm then, PyWrite is able to see that Tcode is bound to employee and so must be employee or more specific, which the number 4 is not. So that's how you can do bounds. It's a much nicer syntax than having to do covariant equals true and bound equals string and all that jazz. So this can be applied to functions as well. So if you were to create a function down here, and we were to say just get the first out of our employee list, and we were to provide a type T, and then we were to do sequence of iterable T, and then return T, return list, sequence, and then the 0th one. So this function first defines a new type var of name T. It is then able to accept an iterable of type T, and then returns the first in the iterable, which will be type T. And you can do that just by using this square bracket syntax here. So if I were to do print first people dot name like this, we'll see that we get no errors, and we also are able to get the first one in the list, which is John in this instance. We can also bound or bind this here. So we can say that we need it to be a list of employee only. And if we did say first of 1 or 2, whoops, just ignore that runtime error. Then we get another typing error with exactly the same stuff as before, saying that literal 1 isn't employee and literal 2 isn't employee because the type is bound to this. If we were to do this, then we get no errors at all, or we would, because we still have this name. But if we were to do this, we get no errors. And PyParameter would take 1. So this is now a more generic function than it was before because we haven't bound it to anything. If we wanted it to only be usable with employees, then we can bind it to employees, and then the type checker would be able to pick something up in a more specific fashion than if we were to just kind of let it do its thing, or if we were to just let the program run. So that is a general overview of the big typing changes in Python 3.12. If you like the video, then make sure to leave a like to let me know, and maybe subscribe if you want to see more videos like this, including further 3.12 videos and a Python 3.13 plans video coming out very soon. If you have any questions or if you have any ideas for future videos, make sure to leave them in the comment section below. I read every single one, so your feedback is greatly appreciated. If you want to support this channel monetarily, you can do so by becoming a member or a patron using the links in the buttons below. £1 a month on either, and you can be on the screen like these people. And I will see you in the next video, where we will probably be talking in more depth about the GIL and what Python 3.12 does with it. So if you're interested with that, make sure to stop by either next week or some point over the month, and I'll see you for that.